You hear water vapor and think Earth, rain, oceans, life as we know it. But on July 31st, 2025, a 30-centimeter telescope floating above Earth's atmosphere caught something breaking every assumption about where water comes from. Neil Gehrels Swift Observatory, ultraviolet light. A faint glow at 3,085 angstroms, hydroxyl, the daughter molecule of water being ripped apart by starlight, coming off something that's been dead cold for 7 billion years. Coming off an object that formed around a star we'll never see. Coming off 3I Atlas, the third interstellar visitor ever confirmed, and it's bleeding water where water shouldn't exist. If you value documented interstellar chemistry and deep space observation like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. This script is researched and factual, using sources from the Astrophysical Journal Letters, published September 30th, 2025, by Zexi Xing and Dennis Bodowitz at Auburn University, and the Archer preprint 2508.0. 4675. Documenting Swift Observatory ultraviolet spectroscopy, peer-reviewed data that directly measures hydroxyl emission at distances where solar system comets stay silent. Now back to the information. Atlas Survey Telescope, Rio Hurtado, Chile. 4.5 astronomical units from the Sun. Something new, hyperbolic trajectory. Eccentricity 6.14, not bound, not ours. Moving 60 kilometers per second faster than escape velocity. The designation comes fast. 3I. Third confirmed interstellar object. After 1, I stroke Oumuamua in 2017. After 2, I stroke Borisov in 2019. But this one's different. This one has a coma. Gas, dust, activity. Classical comet signatures showing up when the object is still farther from the Sun than Jupiter sits from Earth. NASA Infrared Telescope Facility. Every major observatory that can pivot fast enough locks on, because interstellar objects don't wait. They pass through once. One shot, one window. Miss it, and the data's gone forever. Gemini South, GMOS instrument, optical spectroscopy. The spectrum comes back red. 10% slope per 1,000 angstroms between 0.5 and 0.8 microns. Looks like D-type asteroids, dark, carbon-rich. Then they push into near-infrared. July 14th, NASA IRTF on Mauna Kea, Hawaii. SPECS instrument. The spectrum flattens. 3% slope from 0.9 to 1.5 microns. That flattening signature? Water ice grains. Large ones, 10 micron diameter, floating in the coma. Not on the nucleus, in the cloud around it. Bin Yang and the team at Gemini published July 20th. The modeling works with 70% at Tagish Lake meteorite material, 30% water ice. The 2.0 micron absorption band appears. Broad, diluted by a refractory material, but there. Water ice confirmed in the coma of an interstellar object, 25 days after discovery. Almost 3 times farther than Earth. At that distance, surface water ice on a comet doesn't sublimate efficiently. The sunlight's too weak, the temperature's too low. Typical solar system comets at 3 AU are quiet, dormant, barely active. So where's the water ice coming from? Once those chunks are in space, exposed to direct sunlight, they heat up. Small grains, large surface area to volume ratio. They warm faster than the nucleus. The ice sublimates off them, feeds the coma. Creates an extended water source thousands of kilometers from the nucleus. Theory, untested until Swift. Ultraviolet/optical telescope. UVOT. The telescope's in orbit, above the atmosphere. Earth's atmosphere blocks 99% of ultraviolet light below 3,000 angstroms. Ground telescopes can't see it. Space telescopes can. Swift can. 30-centimeter mirror. Not large, but positioned perfectly. Wavelength 3,085 angstroms. Looking for OH. Hydroxyl radicals. When water vapor floats in space and sunlight hits it, ultraviolet photons break the H2O molecule. One hydrogen atom flies off, leaves OH behind. Hydroxyl. The chemical fingerprint, the ultraviolet echo of water. Heliocentric distance, 3.32 astronomical units. The water production rate depends on reddening assumptions between the V filter at 5,437.8 angstroms and the UVW1 filter at 3,325.7 angstroms. For a reddening of 38.6%, the calculation lands at 1.35 plus or minus 0.27 times 10 to the 27th molecules per second, 40 kilograms per second, 88 pounds per second. A fire hose at full blast. That's the comparison Dennis Bodowitz uses. Fire hose at full blast at 3.32 AU from the sun. Minimum. Current upper limits on the nucleus radius from Hubble suggest the nucleus is under 5.6 kilometers diameter. If it's 1 kilometer across, the most likely estimate, that's about 3 square kilometers of total surface. To get 19 square kilometers of active area from a 3 square kilometer object, you need extended sources, icy grains in the coma, sublimating beyond the nucleus, creating water vapor in a shell between 4,000 and 10,000 kilometers from the center. The OH detection before any CN detection is unusual. Cyanide usually shows up first in comets. It fluoresces efficiently in the ultraviolet. Lower atmospheric extinction, higher detector sensitivity compared to OH at 3,085 angstroms. But 3, I-Atlas, shows OH first. Suggests the water is coming from large, dark, icy grains that heat up preferentially and lose their volatile components before cyanide-rich material activates. This places 3I Atlas among the few comets with confirmed OH emission beyond 3 astronomical units, where water ice sublimation is typically inefficient, where most comets go quiet, where the game changes. The detection makes it to the Astrophysical Journal Letters, published September 30th, 2025. Peer-reviewed, confirmed. First detection of hydroxyl from an interstellar object. First water signature from a visitor born in another star system. The ingredients for life's chemistry are not unique to our own. That's the quote. Dennis Bodowitz, the note from another planetary system. August 6th, 2025. James Webb Space Telescope, an IR-spec instrument, near-infrared spectrograph, 3I Atlas at 3.32 AU inbound. The spectrum comes back, and it's not what anyone expected. Carbon dioxide dominates. Completely. The coma is a CO2 fog. Martin Cordner, Catholic University of America, principal investigator. The spectrum spans 0.6 to 5.3 microns. Spectral images, 4 panels. Dust at 1.2 microns. CO2 at 4.3 microns. H2O at 2.7 microns. CO at 4.7 microns. Water, 6.6 plus or minus 0.2 kilograms per second. Carbon monoxide, 14 plus or minus 0.9 kilograms per second. Carbonyl sulfide, 0.4, 3 plus or minus 0.09 kilograms per second. The ratio, CO2 to H2O, 7.6 plus or minus 0.3. Among the highest ever measured in any comet, 4.5 sigma, above the trend for long period and Jupiter family comets. C/2016R2 is the only other comet with a ratio this extreme, but C2016R2 has a clear cometary tail. 3I Atlas does not at this stage. 6.6 kilograms per second from gas phase H2O, but it also detects water ice, solid, in the coma. The absorption features suggest fine grains, smaller than 1 micrometer, likely amorphous ice. Crystalline can't be ruled out. But amorphous fits better. The water ice grains are there, floating, suspended in the carbon dioxide plume, getting hit by sunlight, heating up, sublimating. Feeding the water vapor that Swift detected as OH 2 months later when 3I Atlas was farther in. Cordner, lead author, accepted to Astrophysical Journal Letters. The paper includes Nathaniel Roth, Michael Kelly, Dennis Bodowitz, Stephen Charnley, Maria Drozdovskaya, Davide Farnokia, Marco Micheli, Stephanie Milam, Cyrielle Opitom, Megan Schwamb, Christina Thomas, NASA Goddard, European Space Agency. International team, everyone wants in on this data. The radiation could have cooked the surface, created a processed shell, CO2 ices forming from radiolysis, carbon monoxide oxidizing, building up a carbon dioxide-rich crust. When the sun heats it, that crust outgasses first, violently, launching icy fragments. The high CO2 to water ratio isn't intrinsic to the original formation. It's a scar, a radiation burn from 7 billion years adrift between stars. 3I Atlas formed close to the CO2 frost line in its parent protoplanetary disk, the region where carbon dioxide condenses but water doesn't dominate. That would make the high CO2 intrinsic, baked in from birth. Either way, the comet is CO2 rich and water poor compared to what we're used to. But the water's there, confirmed by 2 independent space telescopes using 2 different methods. Swift in ultraviolet, Webb in near-infrared. Both see water. Both measure it, both publish. It observes 3I Atlas when the comet is at 3.2 AU from the Sun and 2.6 AU from Earth. Multispectral observations. The results? Strong CO2 emission, water ice absorption, no detection of water vapor. Spherex lacks the sensitivity for gas phase water, but the ice is there, bright, extended. Carbon dioxide dominates. CO2 cloud extends to at least 348,000 kilometers. The water ice shows up as absorption features. Solid chunks reflecting sunlight with the telltale dips at 1.5 and 2.0 microns. C. M. Lise and team publish in Research Notes of the AAS. Volume 9, Issue 9, page 242. August 21st, 2025. Third independent confirmation of water in 3 I-Atlas, this time from a mission designed to map the entire sky. As ice grains ejected into the coma by carbon dioxide and carbon monoxide outgassing, those grains sublimate in the extended coma, between 4,000 and 10,000 kilometers from the nucleus, creating the OH that Swift detected, creating the gas phase water that Webb measured, creating an extended water source that operates at distances where surface sublimation fails. X-shooter spectrograph, heliocentric distance 3.78 AU, Rohan Rahat Gaonkar, PhD student, Instituto de Astrofísica Pontificia Universidad Católica de Chile, Daryl Seligman, assistant professor, Michigan State. They're looking for metal emission, and they find it. Nickel, atomic nickel vapor, NI emission lines, 3,210 to 3,255 angstroms, 3,350 to 3,630 angstroms. A forest of nickel lines, getting stronger with each observation. Solar system comets show nickel emission. But here's the anomaly, no iron. Nickel and iron are cosmic twins, born together in supernova ejecta, ejected together, found together in meteorites, in asteroids, in comets, always together. Roughly equal amounts. 3 I-Atlas shows nickel, strong, measurable, rising steadily from July 20th through August 21st. But iron, not detected. 0. No Fe I lines in the spectrum. By August 21st, the VLT measures nickel emission at 4.6 plus or minus 0.7 grams per second, cyanide at 17.6 plus or minus 2 grams per second. The concentrations are similar to solar system comets at equivalent distances, but the absence of iron breaks the pattern. One hypothesis. Nickel tetracarbonyl, Ni parenthesis, CO close parenthesis 4, a volatile organometallic compound. Sublimes at low temperatures, breaks apart under UV light, releases nickel and carbon monoxide, could explain nickel without iron, could explain activity far from the sun. It's a hypothesis, not confirmed, but it fits. August 24th, 2025. Keck the 2 telescope, Hawaii, Keck Cosmic Web Imager, KCWI, narrowband imaging, wavelength ranges 0.3865 to 0.3885 microns for nickel, 0.3605 to 0.3625 microns for cyanide. The images show asymmetric emission profiles, central concentration of nickel relative to cyanide, exponential radius 600 kilometers for nickel, 840 kilometers for cyanide, extensions in both solar and anti-solar directions, evidence for an anti-tail, a plume pointing toward the sun, not away, dust tails point away, pushed by radiation pressure. Gas can point toward the sun if it's part of a fountain flow, or if viewing geometry projects forward scattered material. The Keck data adds detail. W. B. Hugendam and team. October 15th, 2025, published on Avi Loeb's Medium. The anti-tail is real. Multiple telescopes see it. Hubble, July 21st. Keck, August 24th. Unusual but not impossible. 3. I-Atlas sits 3.76 degrees from the sun on the sky. Perfect geometry for absorption spectroscopy. The comets between Earth and the Sun. Radio waves from the Sun pass through the comet's coma. Molecules in the coma absorb specific frequencies. Meerkat detects 2 lines, 1,665 MHz, 1,667 MHz, hydroxyl, OH, the same molecule Swift detected in ultraviolet. Now confirmed in radio, the lines appear at the expected Doppler shifts, textbook comet physics, water vapor broken by sunlight, O's left behind, absorbing radio waves against the sun's emission. Sensitivity wasn't there, geometry was off. October 24th, everything lines up. The detection is reported in an astronomer's telegram by members of the South African Radio Astronomy Observatory and collaborators, posted for the community. Confirmed. The radio signal is not artificial, not a message, not a transmission. It's absorption, chemical fingerprint, natural. The detection aligns with all previous water findings, corroborates Swift, corroborates Webb, adds radio confirmation. 3 independent wavelength regimes, ultraviolet, infrared, radio, all see hydroxyl, all see water's signature, all say comet. Coverage emphasizes what the radio lines mean. They mean water, they mean comet, they mean natural. The Meerkat detection arrives at perihelion. 3I Atlas reaches closest approach October 29th to 30th, 2025. 1.36 AU from the Sun. Between Earth and Mars, then it swings past, reappears from solar glare. Mid-November, visible again. Observers lock on. The water activity continues. July 5th, water ice detected by Gemini and IRTF. July 31st to August 1st, hydroxyl detected by SWIFT. August 6th, water vapor and ice detected by JWST. August 8th to 15th, water ice confirmed by SphereX. October 24th, hydroxyl confirmed by Meerkat radio. 5 separate observations, 5 independent methods, 5 confirmations. The water is real. The OH is real. 3I Atlas is not dry like 1. I stroke Oumuamua. Not just carbon monoxide rich like 2, I stroke Borisov. It has water. It's losing water. 40 kilograms per second at 3 AU. 6.6 kilograms per second in Webb's measurement. The mechanisms differ. The extended source is unusual. The ice grains sublimating beyond the nucleus are rare, but the chemistry is there, documented, measured, published. Stars that formed 7 billion years ago, 2.5 billion years before our sun. The comet could be 7 billion years old, twice Earth's age, the oldest comet humanity has ever studied. It passed within 1 parsec, 3.3 light years, of 25 known stars in the past 10 million years, according to a September 2025 study by Yiyang Guo and collaborators. The parent star? Unknown. But the dynamical membership in the galactic disk tells us it's likely a low metallicity star. Heavy element abundance at least 40% of the sun's. Metal poor, but not extremely so. Gas and dust swirling around a young star. It formed beyond the CO2 frost line, far enough that carbon dioxide could condense. The high CO2 content suggests either formation near that boundary or heavy cosmic ray processing during billions of years in interstellar space. The water ice grains? They represent some of the oldest and most pristine water ever observed. Formed in another planetary system, preserved throughout an interstellar journey that lasted eons, now sublimating in our inner solar system, releasing molecules that might have been locked in place before life began on Earth. Dennis Budowitz at Auburn calls it a note from another planetary system. Every interstellar comet so far has been a surprise. Oumuamua was dry, tumbling, no detectable outgassing, no coma, asteroid-like but shaped wrong, elongated. Cigar or pancake depending on the model. Accelerated away from the sun with no visible jets. Still debated. Still weird. Borisov was carbon monoxide rich. High CO to water ratio. Classic coma. Tail. Behaved like a comet, but with chemistry shifted toward volatiles. Now 3, I Atlas. Water at distances where it shouldn't appear. Carbon dioxide dominating. Nickel without iron. Cyanide rising steadily. Green glow from C2 molecules fluorescing in November. A tail that was hidden in July due to viewing geometry but became visible by August. 30 arcseconds angular length by late August. 56,000 kilometers projected. Growing, changing. Evolving as it approached perihelion. Other gases, CN, C2, C3, OH, and H2, are measured relative to water. Ratios, abundances, depletion factors, enhancement factors. To compare 3I Atlas to solar system comets, you need water measurements. Now we have them. Multiple observations, multiple techniques, consistent results. We can place 3I Atlas on the same scale as homegrown comets. We can ask, does this interstellar object follow solar system trends, or does it break them? The answer, it breaks them. The CO2 to water ratio of 7.6 is 4.5 sigma above the solar system trend. The nickel without iron is unprecedented in natural comets. The extended water source from sublimating ice grains is rare, but seen in a handful of distant comets like C/2017K2 pan-stars. The activity level at 3 to 4 AU is higher than expected. Most long-period comets are dormant that far out. 3I Atlas is active, bright, outgassing heavily. Why? CO starts sublimating around 150 Kelvin. CO2 around 170 Kelvin. Water ice needs temperatures above 200 Kelvin for significant sublimation. At 3 to 4 AU, surface temperatures are around 160 to 180 Kelvin depending on albedo and thermal inertia. Enough for CO and CO2, not enough for water. So the carbon dioxide outgasses, creates pressure, launches ice-coated dust grains. Those grains have high surface area. They absorb sunlight efficiently. heat up above the nucleus temperature, reach the water sublimation threshold locally, start releasing water vapor. Extended source. Explains the SWIFT detection. Explains the Webb detection. Explains the unusual OH detection before CN. High energy protons, heavy ions, radiation doses that would sterilize any biology. That radiation can break chemical bonds, rearrange molecular structures, convert CO to CO2 through radiolysis, create complex organic molecules, build up a processed crust enriched in carbon dioxide and depleted in water. When the sun heats that crust, the CO2 vents first. The cooked shell hypothesis, proposed by Stephanie Milam, fits the data, explains the extreme ratio. Hypothesis 3. Formation location. 3. I Atlas formed just beyond the CO2 frost line in its parent protoplanetary disk. That region is cold enough for CO2 to condense, but might be at the boundary where water ice is less abundant. Depending on the disk's thermal structure, metallicity, and the amount of carbon versus oxygen, you could build a comet with intrinsically high CO2 and lower water content. The ratio would be baked in from formation, not processed, original. This hypothesis requires specific disk conditions, but it's plausible. Cosmic ray processing modifies the surface over billions of years. Sublimation dynamics at large heliocentric distances activate hypervolatiles first, launching ice grains that sublimate in the extended coma. The combined effect, a comet that looks weird from every angle but obeys physics at each step. The water loss rate at 3.32 AU is 40 kilograms per second according to SWIFT. 6.6 kilograms per second according to Webb, the same heliocentric distance but with different measurement apertures and techniques. The discrepancy reflects measurement methods. SWIFT integrates over a large aperture, including extended sources. Webb focuses on the inner coma with higher spatial resolution. Both are correct. Both capture different parts of the water distribution. Together they paint a complete picture. Water from ice grains sublimating in an extended shell. Water from gas phase molecules in the inner coma. Water broken by UV photons into OH that glows at 3085 angstroms and absorbs at 1665 and 1667 megahertz. Water that's been frozen for 7 billion years. Water from another star system. Water that proves the ingredients for life's chemistry are not unique to our own. If you value detailed astronomical research and interstellar object tracking like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script uses data from NASA's Neil Gehrels Swift Observatory published in the Astrophysical Journal. Letters September 30th, 2025. JWST NIR spec observations. Published August 25th on Archive preprint 2508. 0.18209 accepted APJ letters and Meerkat radio detections reported in Astronomer's Telegrams November 2025. All peer-reviewed or observatory-confirmed datasets that establish water presence through converging. Lines of evidence. Now back to the information. Still observable. JWST scheduled for follow-up observations in December 2025. Post-perihelion chemistry. Has the water production increased? Has the CO2 ratio changed? Are new molecules outgassing? Hubble is doing ultraviolet spectroscopy in November, measuring the sulfur to oxygen ratio, tracking compositional changes. The comet will remain within observational reach into early 2026. Then it fades, crosses the orbit of Jupiter. Keeps going, leaves the inner solar system, keeps going, passes Neptune's orbit in the 2030s, keeps going, escapes the solar system entirely, back into interstellar space, back into the void between stars, gone. 5 water detections, multiple telescopes, ultraviolet, infrared, radio, spectroscopy, imaging, photometry. The converging evidence is overwhelming. 3I Atlas has water. It's confirmed. It's measured. It's published. The mechanisms are unusual. The extended source is rare. The CO2 dominance is extreme. But the water is real, and that water connects this ancient interstellar traveler to the chemistry that makes life possible. The water you drink might have started as ice in a comet nucleus 4.6 billion years ago. Early bombardment. Late, heavy bombardment. Comets crashing into a hot young Earth, bringing volatiles, bringing organics, bringing water. If that's how Earth got its water, if comets deliver the oceans, then water-bearing comets might be common throughout the galaxy. Every planetary system with a frost line can make comets. Every star with a protoplanetary disk can build icy bodies. Some get ejected. Gravitational interactions with giant planets, close encounters with other stars, dynamical instabilities, billions of comets launched into interstellar space, wandering, drifting, crossing the galaxy. One of them just passed through our solar system. We caught it. We measured it. We found water. We didn't need to build an interstellar spacecraft. The comet came to us, traveled for billions of years, arrived July 1st, 2025, stayed visible for months, let us measure its chemistry, let us photograph its coma, let us detect its water, let us compare its composition to our own comets, let us learn that water-bearing comets exist elsewhere, that the building blocks of life are widespread, that the chemistry we depend on is not unique. Dennis Bodowitz called it a note from another planetary system. Zexi Xing said every interstellar comet so far has been a surprise. Martin Cordner said the objective is to get the detailed chemical inventory inside this object, and that's going to be really revelatory as far as comparisons with our own solar system. All true, all documented, all published. The Auburn University team's swift observations in the Astrophysical Journal Letters provide the first direct detection of OH emission from an interstellar object. The JWST team's NIR spec observations provide the first infrared spectroscopy of water vapor and ice in an interstellar comet. The Spherex team provides independent confirmation of water ice absorption. The Meerkat team provides the first radio detection of hydroxyl absorption in 3 iAtlas. 5 teams, 5 publications, 5 confirmations. Water, hydroxyl, confirmed. The production rate of 40 kilograms per second is equivalent to filling an Olympic swimming pool in about 16 hours. That's how much water. 3I Atlas was losing on July 31st, August 1st, not from the nucleus. From ice grains in the coma, grains ejected by carbon dioxide jets, grains heating in sunlight, grains sublimating 4 to 10,000 kilometers from the center, creating an extended water source, creating the OH emission that Swift detected, creating the chemical fingerprint that says comet. Collectively, they create enough surface area to sublimate significant water. The ice is likely amorphous. Disordered molecular structure, not crystalline. Amorphous ice forms at very low temperatures, below 130 Kelvin. It fits. 3. iAtlas spent billions of years in interstellar space at temperatures near absolute zero. Any water ice that formed or survived would be amorphous. When it heats, it doesn't convert to crystalline before sublimating. It goes straight from amorphous ice to vapor. That transition releases slightly less energy than crystalline sublimation. But it still requires heat, it still needs sunlight, it still needs those ice grains to be exposed and warming. The carbon dioxide outgassing provides the ejection mechanism. CO2 sublimation pressure launches. Material, dust, ice chunks, fragments. They accelerate away from the nucleus. Once in the coma, solar radiation heats them. The small grain size means they heat fast. Temperature rises, water ice hits sublimation point, vapor streams off, feeds the coma, creates the gas phase water, sunlight hits the water vapor, UV photons split the molecules, O forms. Glows at 3085 angstroms, absorbs at 1665 and 1667 megahertz. Swift sees the glow, Meerkat sees the absorption. Both measure hydroxyl, both confirm water. The detection matters scientifically because it establishes that interstellar comets can carry water. 1 I-stroke Oumuamua was dry, no water, no volatiles, tumbling hyperbolic asteroid. 2 I-stroke Borisov had water, but the ratio was shifted toward carbon monoxide. Now 3 I-Atlas shows water in a different regime. Extended source, ice grains. CO2 dominated, but water present. 3 objects, 3 different water profiles. Oumuamua, none. Borisov, some with high CO. 3 I-Atlas, some with high CO2 and extended distribution. The diversity is real. Interstellar objects vary wildly, just like solar system comets vary, just like asteroids vary. The galaxy produces a range. We're seeing samples. Hypotheses tested. Compositional ratios calculated. Isotopic measurements if possible. Carbon-13 to carbon-12 ratios in CO2. Deuterium to hydrogen ratios in water if spectral resolution allows. Every measurement adds constraints. Every data point narrows the possibilities. Every publication builds the story. Ultraviolet, Swift Observatory, July 31st, August 1st. Infrared, JWST, August 6th, Spherex, August 8th to 15th. Gemini South and NASA, IRTF, July 5th and July 14th. Radio, Meerkat, October 24th. All see water or its signatures, all publish results, all contribute to the converging evidence. The water is real, the OH is real, the chemistry is confirmed. Heliocentric distance at Swift detection, 3.32 AU. Water production rate, 40 kilograms per second, 1.35 times 10 to the 27th molecules per second. Active area required assuming equilibrium sublimation, 19 square kilometers minimum. Extended source sublimation distance, 4,000 to 10,000 kilometers from nucleus. O, emission wavelength, 3,085 angstroms. O, radio absorption wavelengths, 1,665 and 1,667 megahertz. JWST detection, 6.6 kilograms per second water vapor, 129 kilograms per second carbon dioxide. KO2 to H2O ratio, 7.6. Water ice grain size, under 1 micrometer. Ice type, likely amorphous. First detection date, July 5th, 2025 for ice, July 31st for vapor signature. Publication dates, July 20th for Gemini IRTF ice detection on RKIF, August 25th for JWST on AirKIF, September 30th for SWIFT in APJ letters, November for Meerkat in Astronomer's Telegram. 5 confirmations, multiple methods. Peer-reviewed data. Water confirmed in an interstellar comet at 3 AU from the Sun through extended sublimation of ice grains ejected by hypervolatile outgassing. The mechanism is unusual, the chemistry is extreme, but the physics is sound, the observations are real. The water is there. Not a transmission, not a message, not artificial. But for 48 hours, before the astronomer's telegram clarified what they detected, the internet exploded. Alien probe, technological signal. Radio waves from 3I Atlas. The headlines wrote themselves. Then the science came out. Hydroxyl absorption, expected Doppler shift, textbook comet physics, natural origin. The detection actually confirms what Swift found, corroborates the water, adds an independent measurement. Strengthens the case. But the confusion shows how desperate people are for contact, how eager we are to find something artificial, how quickly speculation spreads when rigorous analysis lags. Every observation says comet, water vapor, carbon dioxide, ice grains, coma, tail, nickel emission from volatile compounds breaking down, cyanide from organics, standard cometary molecules at unusual ratios, but standard molecules nonetheless. No transmission, no beacon, no mothership. Just a 7 billion-year-old chunk of ice and rock from another star system passing through ours and letting us measure its chemistry. That's the reality. That's the data. That's what the evidence shows when you read the actual papers instead of the headlines. The note from another planetary system has been read. The message is, water exists elsewhere. The building blocks are widespread. The chemistry that enables life on Earth is not unique to our corner of the galaxy. That's the discovery. That's the breakthrough. That's what the Swift Observatory, the James Webb Space Telescope, Sphere-X, Meerkat, Gemini South, and the NASA Infrared Telescope Facility all confirmed between July and November 2025. Zach Seiching's paper in the Astrophysical Journal Letters, September 30th. Water production rates of the interstellar object. 3I/Atlas. First author, Auburn University. Dennis Bodewitz, co-author. Hydroxyl emission at 3,085 angstroms. Tentative detection at 3.32 AU. Water production rate 40 kilograms per second. Extended source from sublimating ice grains. Active area 19 square kilometers. Unusual for heliocentric distance. Places 3I Atlas among few comets with confirmed OH beyond 3 AU. The paper concludes, detection of OH emission prior to any CN detection is unusual and may reflect differences in grain-driven outgassing or volatile inventory compared to typical comets. While similar behavior has been observed in solar system comets, the mechanisms controlling distant activity and the storage and release of volatiles remain poorly understood. That's the honest science. That's the careful conclusion. That's the appropriate epistemic humility when you're studying the third interstellar object ever detected, and the first one where you catch water sublimating in real time. 3. I-Atlas came from another star system carrying water ice that formed 7 billion years ago. We detected it. We measured it. We published it. The receipts are in the Astrophysical Journal Letters, in RKIF preprints accepted to APJL, in Astronomer's Telegrams, in research notes of the AEAS, Auburn University, Catholic University of America, NASA Goddard, ESO Very Large Telescope, Gemini South, Meerkat, JWST, Sphere-X, Swift. Every major observatory that could pivot fast enough caught this comet and confirmed the water. That's the story. That's the evidence. That's what actually happened when 3I Atlas passed through our solar system and bled water where water shouldn't exist. Meerkat's 64 radio dishes pointed at a dot of light 3.76 degrees from the sun, watching radio waves pass through a cloud of gas, seeing two frequencies dim, 1,665 megahertz, 1,667 megahertz, hydroxyl absorbing, the same hydroxyl Swift saw in ultraviolet, the same signature of water being torn apart by starlight, the chemical echo spanning from UV to radio. Confirmed across the electromagnetic spectrum. water from another planetary system. Confirmed, measured, published, done.